Hello everyone, back to barometers. We're going to cover pressure measurements right now, specifically the different types of pressure. We already looked at the history of barometers. We looked at the theory and also all the different units, and specifically the SI unit for pressure. Now we're going to get into different ways of describing pressure. So here comes a bunch of terms. The first one we're going to look at is absolute pressure, but you can see that there are a lot of different types of pressure. Absolute pressure, also known as total pressure, is the pressure that's exerted by the gas. Whether it's you're moving through a fluid and there's pressure as a result of that motion, or if your barometer or pressure sensing device is static, it's not moving at all. Another type of pressure is differential pressure, and this is simply the difference between two different pressures. It's the pressure relative to some other pressure, so it's the difference between two pressures. The most common example is trying to measure the pressure of a gas in a lab, in a container. So you're taking the difference between the pressure of the gas and the pressure of the atmosphere. Typically this is done using a manometer. Another type of pressure is gauge pressure, and gauge pressure is the pressure that you measure relative to some other pressure, specifically ambient atmospheric pressure for gauge pressure. So gauge pressure, it's in this example you're looking at someone measuring the pressure in their tire. And that's after you take away the atmospheric pressure, you're left with the gauge pressure. So gauge pressure basically is a special type of differential pressure. Another pressure is static pressure. Here's the definition: the pressure in a homogeneous incompressible fluid in steady flow along a level streamline at points other than stagnation point. Wow, what a definition. But what they're saying here, static pressure is basically the pressure that you measure of a fluid if the airplane or whatever is not moving, or if it is moving such that there is no force on your barometer, or no pressure per unit area, or force per unit area, or pressure on your measuring device. An example of this, in airplanes, they have a special static port which is located on the side of the airplane, and it's supposed to measure more or less the atmospheric pressure at that point, or the pressure wherever you are in the atmosphere. So there's really no air impinging upon this, so you don't have a force against it, and you're just trying to measure the air. Basically, if the air was static, if there's no motion of the air, basically. The dynamic pressure is opposite, just a little bit different than the static pressure. It's basically you're trying to measure all of the energy that the air has. So you're trying to measure the force if you slowed it down. This is also known as stagnation pressure. So basically, if you're moving along and you're able somehow to slow the air down, I guess by a flat plate against the wind, as the wind strikes the flat plate, that's the pressure, that's your dynamic pressure. But you have to take away, I should also say, the dynamic pressure is measured by a pitot tube in airplanes, so that's measuring strictly the ram pressure. And it's the difference between the total pressure and also the static pressure. So in other words, take more or less the atmospheric pressure, or the total pressure, including also the motion or the force that's imparted by the motion of the air. Take away from that the static pressure, just the basic atmospheric pressure, and you have more or less the ram pressure, the pressure that's a result of the air moving and striking a plate, and that is your dynamic pressure. A few other pressures we'll wrap up with here now. Atmospheric pressure is the pressure, more or less, that's exerted by the atmosphere just because of the gravitational attraction of the Earth. So the Earth is pulling down on the air. More or less, you can think of this as kind of the weight per unit area of the atmosphere. And this is what we use barometers to measure: atmospheric pressure. Atmospheric pressure, as I said, is a consequence of the weight in a column of air above a given unit of area. And there are lots of different ways to describe atmospheric pressure. These are all standard atmospheric pressure values. 1 atmosphere is equal to, you're probably familiar with 1013.25 millibars, but there's the conversions in inches of mercury. For those of you who fly, you probably know 2992 as a standard atmosphere, but also there it is in hectopascals and also pounds per square inch and other values. Station pressure is what a barometer actually measures. It's the pressure that's measured by an instrument after you take care of all the calibrations and making all the corrections to the barometer. But it's not the pressure that you would see at sea level. In other words, well, here's a picture. A picture's worth 1,000 words. Oh, that's not a picture. I guess next is sea level, and then we'll take a look at the picture. Sea level pressure is the pressure that you would expect at sea level, but you would measure it, someplace else in the atmosphere, higher in the atmosphere, and then bring it down empirically using equations to hypothetically create a pressure that would be what you would normally see at sea level. Okay, that sounds kind of complicated. Let's look at the picture. There's the picture. And for example, you may be in a location on the top of a mountain or someplace where you're at a higher elevation, and the station pressure is what you would actually measure, the pressure there. In this case, at 5,000 feet, would be probably someplace close to 850 millibars. But sea level pressure, if you take that pressure, 850 millibars, and then use an equation and hypothetically bring it down to sea level, that would be your sea level pressure, down to 0 millibars. So that is how they do sea level pressure. We're going to do some calculations of sea level pressure, and we'll talk about that in class, and also you'll do that in lab. The last couple of things I want to mention is the different types of pressure measurements. You can have either direct or indirect. Direct is where you actually measure what you're trying to measure, the force of the per unit area of the atmosphere, the weight of the atmosphere, using a barometer. Whereas indirect is where you measure pressure by some other phenomena that's related to pressure. A good example, and this is one type of barometer, is you can measure the boiling point at which a liquid boils once it's exposed to atmospheric pressure, because you know that the boiling point is a function of pressure. As pressure goes down, the boiling point also decreases in temperature. So you can actually measure the boiling point, and you could see the boiling point and then from that infer atmospheric pressure. That would be an indirect measurement. That's all I have for you for this video, and we'll see you in class.